Hello friends! Before we get started, you should have a game scene in your project which contains a character that the player can control and a level they can walk around in. You should have at least 2 or 3 different level scenes ready to connect together when the player walks past a threshold. Throughout this course, we will add elements that are essential to any type of game you can think of, including menus, scene and level transitions, fading both visuals and audio, settings, credits, and data persistence. You can use your own project to follow along with this course, or download a starter project from my GitHub titled Godot Essentials Course, Main Branch. Your project can be 2D or 3D and almost any game genre that involves moving a character between different scenes. Let's start by allowing the player to pause the game. Opening the project settings and switching to the Input Map tab, we can add a new action for pause and click on the Add button. Scrolling down, finding our new pause action, we can add events which will trigger this pause action by clicking on the plus button. I'll use the escape key and the start button on my controller. We've been using the player node to handle our game's input through the attached player script and relaying the appropriate information to move the character or the spring arm and camera. Like we did with the run and jump buttons, we can check if the pause button was pressed. But we don't want to pause the character or the camera, we want to pause the entire scene. We can grab a reference to the scene's root node by exporting another variable. Let's call it _GM, short for Game Manager. But the value of this variable shouldn't ever really need to be changed. It should always be the root node of the game scene. Instead of @export, we could use @onReady to set the value of our GM variable to getParent, since the player node is a child of the game node. But we may not want to rely on this exact structure in order for our script to work properly. We may, for instance, want the player node to be a child of the character node for other reasons. So to make this reference always point directly to the scene's root node, we can use the $sign annotation. Starting the node path with /root/, we'll start at the scene tree's root. But it's important to note that this is not yet the game scene node. We also need to add the name of the root node to this node path, root/game. If we run our current scene, then switch to the remote view in the scene panel, we can see that the scene tree's root node is named root, and currently the root's only child node is the game node. Now that our player node has a direct reference to the scene's root node, let's call a function on it that we haven't written yet, togglePause. Attaching a new script to our game node, this script will be responsible for managing the scene as a whole. We'll call it Game Manager. Much like a manager in a workplace, this script's job will be to open the scene when it first starts, make sure all the employees or child nodes have everything that they need to do their individual jobs, then close the scene when it's finished. Since our simple game only has one mode of play, we only need one game manager. But a more complex game with multiple game scenes might have an exploration manager, battle manager, puzzle manager, and so on for different gameplay scenes. In our new game manager script, we can add the togglePause function we called from the player script. Pausing the game is actually quite simple. We will start by getting a reference to the entire scene tree with a built-in function getTree. The return type of this method is a scene tree, which contains a variable named paused that we can access with a period. The type of the paused variable is a boolean, which has a default value of false. Setting the value to true pauses the game. We can switch the value back and forth between true and false every time this toggle pause function is called using the not logic operator, represented with an exclamation point. Setting the value of paused to not false the first time and then not true the second, and repeating. If we test it out, we can pause the game, but we can't unpause yet. This is because the player node, which is trying to receive the input to unpause the game, is also paused and can't receive or process input. Some specific nodes we might not want to pause while the game is paused. Selecting the player node in the scene tree, look in the inspector under Node and expand the Process section. The mode property is currently set to inherit, which means that it will inherit the same process mode as its parent, the game node. Since the game node is paused, the player node will also pause. We can change this value to always, so the player node will always process even when the game is paused. Note that we can also make nodes pausable, have some nodes only process while the game is paused, or disable processing from certain nodes altogether. Now when we run the scene, we can pause and unpause the game since the player node is always running regardless. But this creates a new problem. If we pause the game and press the jump button, then unpause, the character jumps. If we do not want this behavior, we need to return to the player script. Let's first move the check for the pause button to the top of the input function. Then if the tree is paused, ignore any further inputs by returning. And do the same in the process function to ignore the movement and camera controls too. Now when the game is paused, the only input the player can give is to unpause the game. Everything else will be ignored. Lastly, I would like to display a menu on the screen with some buttons while the game is paused. But before we do anything involving the user interface, we should configure the game's window size. Open the project settings and switch to the General tab. Selecting Window, we can set the size property to set the window size of our game. Optimal window size will depend on your target platform. I'll use 1280 by 720 pixels. So far, everything in our scene tree is being observed by the camera to produce a 2D image, which is what we see in our window when we play the game. This 2D image being rendered by our camera is layer 0 of the 2D display. We can add additional layers to our game's display after the camera has finished its rendering using a new node type, a canvas layer node. The default layer of a canvas layer node is 1, so it will be drawn over layer 0. If we want, we can add any number of layers to draw in front of or behind our game. Let's rename the canvas layer node to UI, short for User Interface. Right-clicking on the UI node and selecting Add Child Node, let's add a label node to the canvas. This switches our view to 2D. So far we've only been working with default nodes like the player node and 3D nodes for everything else. Our canvas will use a different family of nodes called control nodes, which have green icons. I'll rename this node to Title and set its property to say Pause. Next, let's repeat the process to add a button. And name the button Continue. Then edit the button's text to say the same. Zoom and pan so you can see the blue rectangle to the right of the green y-axis and below the red x-axis. This is the viewport of the game window. Our nodes were added at the scene origin, so they will be rendered in the top left corner of the screen if we play the game. But they are overlapping. Let's organize these nodes using another control node, a vertical box container. A vertical box container doesn't actually draw anything, but will organize its children to a line vertically. making organization faster than if we were to manually position each node. Selecting both title and continue nodes, we can click and drag to reparent them to the vertical box node, and see that they are automatically reorganized. Let's also duplicate the continue button to create another button, and name this one exit. Then edit the text property to match. The vertical box automatically adjusted itself to accommodate the extra button. Let's rename the vertical box to pause menu. With the pause menu node selected, expand the layout section. The anchor's preset value is currently set to top left. We can easily anchor the pause menu to any corner, edge, or the center of the screen. The anchors are represented in the preview by these 4 green pins, which we can individually click and drag around the screen. The anchors determine the node's position or size in relation to the window size we set in the project settings, expressed as a percentage. We can also use custom anchors if we want to. For example, use only the upper 10% of the screen for a menu bar, or maybe use the middle third of the screen to display a scoreboard. I'll anchor my pause menu to the center of the screen, and also set the title's horizontal alignment to be centered to match the buttons. With the pause menu created, let's set its visible property to false by default by clicking on the eye icon beside it in the scene tree. Then in the Game Manager script, we can use @onReady to get a reference to the pause menu node. Using a $sign to specify a node path, using quotation marks because the name contains a space, going through the UI node to access the pause menu node. When the game is paused or unpaused, we can set the visible property of the pause menu to match the paused value of the tree. So now we have a pause menu with buttons, but how do we know when the buttons are pressed, and what do we do when they are pressed? If we select the Exit button in the scene tree, we can switch the Inspector tab to the Node tab, which will display signals by default. If groups are displayed, you can switch to signals by clicking here. Here we can see a variety of signals that this node will emit under different conditions. The button node will emit a signal when it is pressed. All we have to do is connect this signal to a function, either by double-clicking on it or right-clicking and selecting Connect. In the window, we can select any node in our scene tree, which will listen for this signal to be emitted. If we select the Game Manager node, the receiver method field will say onExitPressed, which is the name of the function which will be created for us when we click Connect. Our view will automatically switch to script and display the Game Manager script, which now contains the onExitPressed function. This function will now be called automatically when the exit button is pressed by the player. A green connection icon is displayed next to the function definition to tell us that this function is being called by a signal. And the exit button in the scene tree has a signal icon to tell us that this node can emit a signal which is connected to a receiver. For now, let's just print to the output a message saying return to title scene, both so we know it works and to remind us to implement this feature later. Selecting the Continue button, we can also connect its pressed signal to the Game Manager node, but this time click on the Pick button, and pick the toggle pause function we wrote earlier. Lastly, we need this node to process while the game is paused. So let's change its process mode to when paused. Let's try it out. We can pause the game, clicking the exit button displays our message, and pressing the continue button unpauses the game. Once the menu buttons have focus, we can also use the arrow keys to navigate between the buttons and the spacebar to press them. Let's make this work with our game controller as well with just a couple more simple steps. Opening the project settings, the Input Map tab, click on the Show Built-in Actions toggle to see the actions that were used. The controller's D-pad is already listed under UI left, right, up, and down for navigating menus. But we need to add a controller input to the UI accept action to be able to press the buttons. I'll use the bottom action button, which is A on my controller. Now we just need the menu to grab focus when it is opened. Adding a script to the pause menu node, we'll just name it menu. We'll export a variable to hold the menu item, which should grab focus by default when the menu is opened, of type control. I'll assign the continue button to be the default focus item in the inspector by clicking and dragging it into the field. Creating a public function, let's call it open, we can set the visible property to true and also tell the default focus item to grab focus. And another function, close, will set the visible property back to false. Back in the Game Manager script, instead of setting the visible property of the pause menu directly, we can call either open or closed based on the value of paused using an if statement. Running the scene, using only a controller, we can pause the game, navigate the menu, and press the buttons. We now have a pause menu that is presented to the player when they press the pause button. In the next lesson, we'll build a title scene for our game. I'll see you in the next lesson.